السلام عليكم ورحمة الله وبركاته. حبايبنا طلبة ثالثة ثانوي، أهلا بكم في دروس مادة الفيزيكس. معكم مستر محمود حافظ، سينيور فيزيكس تيتشر في مدرسة حسن أبو بكر الرسمية لغات. هنبدأ إن شاء الله دلوقتي مع ليسون 1 اللي هو الإلكتريك كارنت. What we mean by electric current? Electric current, it is a flow of a charge inside a conductor. Suppose we have a wire. When the electric current passes through the wire, so we have electric current. The material here divided into three types. The material which carries the electric current. We have conductor and semi-conductor. Number 3, insulators. Conductors as metals which have free electrons, so it can be able to carry the electrons to move from one point to another inside the wire. Number 2, semiconductors as silicon, germanium, which conducting electricity depend on the temperature. It's intermediate between metals and non-metals, so we can use it in electric circuits or electronic circuits in the making a processor. Number 3, insulators don't have any free electrons or free charge, has a lack of free charge, so it can't conduct the electricity. Here, the electric current, we have two types of electric current, depends on the direction of the electric current. Suppose we have a battery. This is the positive and the negative. Positive and negative. The direction in the wire out the battery. The battery is the source of the electric current. It has two poles, positive and the negative. The positive pole, when the electric current, we have a direction here, moved from positive inside the wire to the negative pole. This is called the conventional current. Number 2, actual current. Actual current, when we make the electric current to move from the negative pole of the battery inside the external wire or inside the circuit to the positive pole of the battery. Okay, we will take this direction as a commonly in the electric circuits. Now we'll discuss three properties of the electric current. Number 1, if we have electric current and the electric current electrons moved inside the wire, so we have electric current intensity and potential difference. And third property of the electric current is the resistance. Firstly, we'll discuss the electric current. What we mean by electric current intensity? Electric current intensity, it is the quantity of a charge passed through certain cross section of the electric wire in 1 second. So suppose we have the electric charge pass from the cross section in 1 second. The quantity of a charge equals 10 coulomb pass in 2 seconds. So we have 5 coulomb in 1 second. This is called electric current intensity. We can call it 5 ampere. Okay, the quantity of charge which can pass through the wire or the cross-sectional area of the wire, we can call it N times E to verify Q. Q, it is the quantity of charge, its measuring unit is coulomb. N, number of electrons passes through, and E, the charge of electron 1.6 has a certain value and a fixed value, multiply 10 power negative 19 coulomb. So from this rule we can calculate the quantity of a charge, and finally we can calculate the quantity of a charge, the electric current intensity, Q over T. So coulomb per second, which equals ampere. We can measure the electric current intensity in the circuit by using a meter. A meter is connected in series as the positive pole of the battery with the positive pole of a meter, the negative pole of the battery to the negative pole of a meter. Okay, here we have unit of electric current intensity, which is ampere, has equivalent unit which is coulomb per second. The electric current intensity is directly proportional to the quantity of charge. By increasing the quantity of charge, the electric current intensity will increase at the same time. Here we have three definitions. Number one, what we mean by ampere. Ampere, it is the electric current intensity when the quantity of charge equals 1 coulomb pass in 1 second. Okay. Number two, what we mean by coulomb. Coulomb is the quantity of charge that passes through a certain cross-section area to produce 1 ampere in time equals 1 second. Number two, we'll discuss the relation. Here, suppose we have a wire. This wire contains electrical charge. A certain electrical charge pass in quantity of charge pass in a certain cross-section area in a certain time. Suppose we have 1 second. Okay, we have 10 coulomb pass in 1 second, so the electrical current intensity will be 10 ampere. Okay, to graphic representation, to draw graphic representation between I and t. In this case, the quantity of charge is constant, so the electric current intensity 10 coulomb in each second 10 coulomb, so we can write it as the following. So the electric current intensity is constant because the quantity of charge is constant and the time is constant, passing regularly through the cross-sectional area. Number two, we'll discuss what we mean by potential difference. The potential difference here, suppose we have a piece of wire is a part of electric circuit, have two poles. This is connected to the negative pole of the battery and this part is connected to the positive pole of the battery, so we have potential difference between them. The quantity of charge are different, so we have high potential and low potential. The actual current moved from high potential to low potential, okay, from the quantity of charge or higher quantity of charge to lower quantity of charge. Here we have a potential difference because the work done to transfer, work done to transfer the quantity of charge from one point to another. We can calculate potential difference in this case in W over Q. W is the work done to transfer the quantity of charge equals 1 coulomb. Suppose we have 1 coulomb, so V equals W when we transfer 1 coulomb between the 2 points, and we can define it as the following. Here the unit is called volt, here joule and coulomb. So volt is the potential difference which needs 1 joule to transfer quantity of charge equals 1 coulomb. Joule in electricity means the work done when the potential difference equals 1 volt to transfer quantity of charge between a certain point which equals 1 coulomb. Okay, coulomb here from this law is the quantity of charge which transferred by work done equals 1 joule between 2 points. The potential difference between them equals 1 volt. If we have a wire and this wire contains equal number of charge, so there is no electric current because the electric current depends on the potential difference between them. If there is no potential difference, there is no electric current passes through the wire. This is number 2. Number 3, we'll discuss the potential difference inside the battery. Suppose we have a battery as the following. Here it is a positive pole and the negative pole. Negative pole means it contains large number or quantity of a charge. Number 2, here positive pole contains a small number of a charge. Here we discuss the actual current inside the battery and inside the circuit. We will make a key and a resistance. Okay, so the electrons passes through the wire between the 2 poles of the battery is called, we have a potential difference between them which is called electromotive force of the battery. So the potential difference between the 2 poles of the battery or electromotive force between the two poles of the battery is the work done to transfer a quantity of a charge between the two poles of the battery and in outside the circuit. Out the two poles of the battery inside the circuit. Okay, so electromotive force of the battery is a type of potential difference but between the two poles of the battery. So the work done to transfer the charge inside and outside the battery is called electromotive force. Here we have three types of V. Here we have three types of V. V inside the wire, which is called the potential difference. Number two, here it is the electric state of a conductor, which expresses the transferring of energy from high potential to low potential. Number three, the potential difference between the two poles of the battery, which expressed as electromotive force of the battery. This is number two. If we wanted to calculate the relation between potential difference and work done, we will write it as the following: by increasing V, W, and V. As the potential difference increases, the work done to transfer the quantity of charge will increase. So we can summarize it as the following. Okay. Now we'll discuss the third part, which is called electric resistance. Suppose we have a wire. This wire have particles, the building unit of the material of the wire, and we want to pass the electrons inside the wire. So the electron will pass and hit the particles till it moves outside the wire or passes through the wire. This is called opposition to flow of the electric charge, which is called is electric resistance. We can summarize it, we can brief it as R. So R is the opposition of flowing the electric charge inside the conductor by the molecules of the wire. This R depends on, by increasing the length, this wire has area and L1, this is L2, as L2 is greater than L1, same material, same cross-section area, so wire 1 has R1, wire 2 has R2. So R1 over R2 equals L1 over L2 because they have direct relationship. Number two, the factors, second factors which control the electric resistance of a conductor is the area 1 and the area 2. The same length of the wire, the same material, so we have different cross-section areas. This is called R1, this is called R2, so R1 over R2 equals area 2 over area 1. This is inverse relationship. By increasing the cross-section area, the resistance of the wire will decrease. Number three, the type of material. We made the electric wires from copper because copper has low electric resistance material. Sometimes we will make it from aluminum because aluminum has lower electric resistance. So we can't make it from iron because iron has higher electric resistance and be able to be rust. So we can't make it from iron. This is called resistivity. Resistivity, it is the resistance which depends on the type of material. Here R directly proportional with L, or inversely proportional with area. So R directly with L, inversely with area. We will make a constant here. R equals rho E L over E. This is the law of electric resistance. Okay, we have two factors: L length, A area, and rho E. Rho E is the resistance depends on the type of material. Type. Here the factors affected rho E. Rho E depends on two factors. Number one, temperature. By increasing the temperature, rho E will increase. There is a direct relationship because the movement of the electrons will increase. The vibrational movement of the particles will take a bigger range, so it will prevent the electrons from passing through the wire. Number two, the type of material. The electric resistance of copper is different from electric resistance of aluminum, so it is the characteristics, physical property of material depends on the type of material and the temperature. Rho E equals RA divided L. So we can conclude the unit of rho E from this rule. Here R ohm, area meter square, length in meter, simplify them, equals ohm dot meter. It is the unit of resistance. We have another physical quantity which is called conductivity. Conductivity is a reciprocal of resistivity. So resistivity equals 1 over conductivity, which is called sigma. Sigma equals 1 over resistivity. Sigma in ohm -1, meter -1, which is called Simon. Simon is the equivalent unit of ohm -1, meter -1. This is the factors of electric resistance. We will discuss the type of resistance. We have two types of resistance. Number one, fixed resistance, which has a fixed length, which is called R. Number two, variable resistance, which is called RV. We can call it as a rheostat, which is used in the electric circuit to change the length of the wire. By changing the length of the wire, we can change the value of the resistance, electric resistance, to control the electric current passes through the wire. Now we will discuss the relation R, which is the link between V and I by law, which is called Ohm's law. The circuit of Ohm's law can be written as the following. It is a battery, variable resistance, ammeter, fixed resistance, voltmeter, and the key. Okay, this circuit is used to verify Ohm's law. Here V I R V over I. This is 10 ohm. Firstly, we will move the slider of the rheostat to obtain a highest number of the resistance, or RV. So the slider will begin from the beginning of the RV. Here we will have electric current. The reading of a meter equals 0.1. The voltmeter equals 1 volt. So the ratio between them equals 10. V over I equals 10, which is equal to R, 10 ohm. By changing the position of sliding rheostat, we will obtain 0.2. The voltmeter reading equals 2. By dividing them equals 10. So it's equal to R. Changing the value of RV will decrease the length. The electric current will increase to 0.3, to 3, 10, and finally we have 10. So from this graph we can conclude the following. At constant temperature, the ratio I over R equals R, V over I equals R, and I directly proportional with V, V directly proportional with I. Okay, this is called the mathematical formula of Ohm's law. At constant temperature, electric current intensity is directly proportional to the potential difference at constant temperature. Okay? The factors and the law, we have another law. Here, V, I, and R in volt, ampere, and ohm. R is the ratio between the potential difference and the electric current intensity. R is the opposition or obstruction of the electric current that passes through the wire. Okay? Number 2, ohm. Ohm is the ratio between volt and ampere. Ohm means resistance which equals 1 ohm when the potential difference equals 1 volt and electric current intensity equals 1 ampere. Ampere is electric current intensity passes through a resistance which equals 1 ohm when the potential difference between 2 points of the resistance equals 1 volt. Volt is the potential difference between 2 points when the electric current passes through them, between them, equals 1 ampere, and the resistance between the 2 points equals 1 ohm. Okay? Here we have 3 definitions. Actually we have 6 definitions in this part. Electric resistance, electric current intensity, potential difference, and ohm, volt, ampere. We can collect the laws of the electric current in the following figure. Here, work done, V, Q, V, I, R from Ohm's law, Q, I, T from the definition of electric current intensity. Here in joule, Q coulomb, V volt, second, ampere, ohm, ampere. We can conclude new laws from this figure. Here W equals VQ, W equals IRIT, I power 2 RT. W is the work done in joules. Okay? VQ equals I power 2 RT. طيب, what about the power? The power means the quantity of energy which consumed inside the wire in 1 second. So the power here equals W divided T, which equals VQ divided T, which equals I power 2 RT divided T, which equals, by simplifying, I power 2 R. Power unit is watt. So watt can be equals, has many equivalent units. Maybe joule per second, number 1. Number 2, volt coulomb per second. Number 3, ampere square ohm, which is equals I power 2 R. Okay? We can here write some graphic representation for the laws. Here, the work done by the time direct relationship, while the power and the time is constant. Okay? By increasing the time, the work done will increase, but the ratio between them is constant, which equals power. Power مع time is constant. This is the equivalent units and the discussion of power. Power means the energy consumed inside the wire when the electric current passes through it. Suppose we have here a battery, ammeter, voltmeter, key. This is variable resistance, which is called RV. What happens to the reading of a meter and voltmeter by increasing the value of RV? Here, the ratio, the graphic representation between a meter reading electric current intensity and RV is inverse relationship. By increasing the resistance, the current will decrease. Another one, here, By increasing RV, V with RV, V is constant because V is the potential difference between the 2 points of RV. At the same time, it is the potential difference between the 2 poles of the battery. So the potential difference between 2 poles of the battery appears as a constant during this circuit. اوكي. طيب لحد كده يبقى احنا الحمد لله قدرنا نناقش الالكتريك كارنت انتنسيتي، بس في شويه ايدياز للبروبلمز. تعالى مع بعض نشوف الايدياز بتاعت البروبلمز. Here we have electric current intensity, we have potential difference R, RV, we have power. Okay, so suppose we have a wire. This wire has a length. We change the wire into a circular loop. The circular loop has a radius. This radius equals 7 meters. With a certain number of loops equals 100 loop. So we can conclude the length of the wire. The length of the wire here, L, equals 2 pi r, which expresses the circumference of the wire, the circumference of the circuit, of the circle, multiply n. So 2 multiply 22 over 7, multiply r 7 meters, multiply 100 will be equals 4400 meter. It is the length of the wire. Okay, another one, we can differentiate between rho e and rho. Rho is the density of material, which equals mass over volume, but rho e equals or A over L. This is the resistivity of the wires. This is the density of material. We can find the relation between them as R equals rho E L divided A. Here volume equals area multiply length. So we can substitute rho equals mass over area L. So area will be equals mass divided rho L. By substituting in the main law, so rho E L divided area M over rho L. So finally we have rho E rho L power 2 over M. This is for R. To make a comparison between two wires, the first one has R1 and the second one has R2 will be equals rho E rho L power 2 to M. So R1 divided R2 will be equals rho E rho L1 square divided M1 for the first wire, multiply M2 divided rho E rho L2 square. Okay, so they have the same material, so rho E rho with rho. Finally we will have L1 square M2 divided L2 square M1. This is the ratio between the two wires. The graphic representation for the relation R and area is inverse relationship. The graphic representation between rho E and sigma is inverse relationship. The graphic representation between rho E and 1 over sigma is direct relationship, and this is 45 degree. Okay, And finally we have the last graph. The last graph is between sigma and area. Sigma doesn't depend on the area, so it will constant because it depends on the type of material, doesn't depend on the length, doesn't depend on the area, it depends on the type of material and the temperature. بكده يكون ناقشنا النقط المهمة اللي موجودة في lesson number 1. ان شاء الله في المرات اللي جايه هنكون مزودين الاكسرسايز، هنكون مزودين السولفد بروبلمز باذن الله. والسلام عليكم ورحمه الله وبركاته.